Welcome you all my lecture series of data structures. In today's video we are going to see about that AVL tree. So AVL, before in the last video we have seen that binary search tree. So what is the drawback in binary search tree means? This is an example. Suppose you want to in types of binary search tree we have at several types. One is the right skewed and left skewed. Suppose you are inserting element in the only in the right child means the tree is imbalanced. So so we have to do that lot of so in the tree is growing on the only one side. So this is the drawback of that binary search tree. So it produces an unbalanced tree. To overcome that balancing tree, we are going to the concept of AVL tree. So in the AVL tree, it is a binary search tree, but in which for every node in the tree, the height of the left and right subtree is differ by at most 1. So this is the important factor you have to consider in the AVL tree, that is called it as a balance factor. So AVL tree, we are having the balance factor concept, that property. So in the balancing factor means we have to find the balance factor of every node in every insertion or deletion. So the balance factor is equal to the height of the left subtree minus height of the right subtree. So that balance factor should be contains the three values 0, 1 and minus 1. So that means the tree is balanced. So this is the main property of an AVL tree. So the AVL tree means it is a BS tree and also contains the balance factor of every height of the node should be minus 1, 1 and 0. So when the tree is imbalanced, so we have the four cases that AVL tree is imbalanced. One is case 1, the insertion into the left subtree of left child means the tree is imbalanced. Insertion into the left subtree of left child. In another case, the insertion into the right subtree of the left child. The right subtree of the left child we have a imbalance, that is a case 2. In case 3, insertion into the left subtree of right child. So that is a thing we are going to insert means the tree is imbalanced. So the case 4, insertion into the right subtree of right child. So these are all the four cases the AVL tree is imbalanced. So in terms of imbalance, what we have to do mean we have to do the rotation in the AVL tree. So why we do that rotation means we have to maintain the balance factor as minus 1, 1 and 0. For that constraints we are doing that rotation whenever we face the imbalance in the AVL tree. So the rotation means it contains a single rotation and double rotation. The single rotation is comes in the case of case 1 and case 4. That means we are going to insert the left subtree and left child, do the right rotation. And case 4, when you are inserting right subtree of right child, that is an imbalance means we have to rotate the tree in the left rotation. So in case 2 and 3, we have to do the 2 rotation, that is a double rotation comes in that case 2 and 3. So that is that case 2 is when you are going to insert the right subtree, left child in the right subtree. Left child in the right subtree means we have to first do the right operation and left operation. Case 3, when you are going to insert the element in the left subtree of right child means first we have to do the left rotation, after that we do the right rotation. So the double rotation is a left and right and left, LR or RL rotation. So this is a introduction to the AVL tree. Whenever we do that insertion and deletion operation, we have to check the tree is imbalanced or not. If it is not means we have to do the rotation. For example, there is a scenario where the tree is imbalanced. So suppose you want to insert the element in the order of x, y, z. So x, y, z means right subtree, right child. So what is the rotation we are doing? you are doing the single left rotation. Suppose when you are inserting x means what is the balance factor is 0. Again you are going to insert the y means it is a BST. So in terms of alphabetical order, y is comes in the right side of x. So x tends x, then right side of y. Now what is the balance factor of y is 0, x is -1. Next you are going to insert z means we are going to inserting in the right subtree of right side of x. So that time z is 0 and y is -1 but x is -2. So there is a imbalance. So when you are need that imbalance, whenever you find out the balance factor is exceed -2 or +2 means we have to rotate the three nodes in that and the under two nodes. So the xy z மூணே சேர்த்து we have to rotate. So after rotation, the middle element, that is a y is comes to that root, and x is left and z is right of y. So this is the single left rotation. Suppose there is a scenario we are going to insert the z y x means z means first z is inserted as a root, y means that is a left, then x is again a left of y. So here there is a situation that we are going to insert the left subtree of left child, means what the rotation we have to do, single right rotation. So this is the terms of scenario we are going to do the rotations. Double rotations means the order of x, z, y, we are going to insert the right subtree of left child. So we do that. First we are doing that right rotation, then left rotation. For any rotation, the middle element comes to the root. The remaining lesser element of middle is left hand side and another element is the right hand side. This is that introduction to the AVL tree and how we can do the rotations in that AVL tree in terms of when the tree is imbalanced. Thank you.